Good evening. My name is Kevin Tong, and my project is Continue TED, Continue Learning Beyond TEDlium. The TEDlium dataset is well known and widely used for training and evaluating speech recognition models. This dataset has several advantages. For example, it covers a very diverse vocabulary and also have speakers with various accents. The TEDlium models also performs well in recognizing structured speeches because they are trained on TED Talks. So these are formal speeches that are well rehearsed, well organized, and are recorded with high quality. Despite these models' good performance, they still have some disadvantages. For example, the performance of these models tend to degrade when we use them to recognize informal speeches. Also, these models have limited capabilities in processing speaker overlaps. They also do not cope well with background noises. So how can we mitigate these disadvantages? A very straightforward way is to train a new model with a combined data set, right? Let's combine both data from formal and informal speeches and train a new model. However, this can be costly because we're looking at hours and hours of training data. Another way is to train models incrementally, right? Let's start from a base model and then fit this model to a new domain. However, these models' performance tend to degrade due to a phenomenon called catastrophic forgetting. So the problem we're trying to solve in this project is how to expand the applicability of TEDlium models to the informal speech domain stepwise, while maintaining good performance on both formal and informal domains. The method we're going to rely on is called continual learning. And some state-of-the-art methods in this area are elastic weight consolidation, which poses a penalty when we modify the parameters that are important for old tasks. Learning without forgetting uses knowledge distillation to preserve old knowledge, old information, and progressive neural networks introduce a new section of the network, introduce a new section to the model when we add a new task. We plan to use two data sets in this project. The first one is obviously TEDlium 3 dataset, and the second one is the ICSI corpus dataset. It contains recordings for ICSI meeting audios, and that's about 70 hours. So our approach is to first train a TDN model with KLD on the TEDlium 3 dataset, and then we apply elastic weight consolidation and continue to train this model on the ICSI dataset to adopt the model to this new domain. And eventually, we evaluate the performance of the new model using both datasets. We expect to see this new model maintains its 10% word error rate on data from TEDlium dataset, and we'd also expect to see that this new model achieves a near 10% word error rate on ICSI dataset.